questions 13 and 14. So 13 asks if f is defined at 2, and I can see that it's not. If I were to look at the graph, I could see at 2 that there's a hole in the graph, but there's no other dot filled in anywhere near 2 whatsoever. If I were to look just at the algebraic expression of it, this rule is good for x values that are less than 2. This rule is good. This rule is good for x's that are less than 2. This rule is good for x's that are more than 2. But if someone were to say, "Hey, what's the rule for at 2?" I'd be like, "I can't tell. There isn't one based on this function, and there isn't one based on that graph. We don't know. There's no y value associated with 2, so it's not." Is it continuous at 2? No, of course not. It can't be. In order for it to be continuous, it has to exist, and it has to match the limit. So it doesn't exist. It's a hole in the graph, not continuous at 2. And then for 14, at what values of x is f continuous, we can just kind of look at where all the, like the way I got these values, if I were looking at this rule here, I would focus very carefully on each of these x values where they're recognizing that weird things are happening. So I'd check out what's happening 0, 1, and 2. And I would see, I want to check certain things. Like right off the bat, I would know, for instance, that 2 is not, whoopsie doodles, 2 is not a good place. It's not going to be a point of continuity because the function's not even defined at 2. At 1, I'd have a little bit more work to do, and we did all that work up here in number 12. So you'd have to check the limit exists, you'd have to check that the limit and the function match, and it's not the case. So getting an equation and answering question 14 is a little more challenging, but when you have the graph, it's like pretty easy. You're basically just going to look at this graph, and you're going to try to decide where the breaks and the holes are. So if I were looking at this graph, I would notice a break here when x is 0. I would notice a hole here when x is 1, and I would notice a hole here when x is 2, and I would also notice that the function is continuous everywhere else, that it's defined. So that where it's defined part's pretty important. And I also am not going to include the endpoints in my intervals of continuity, although some textbooks do and some textbooks don't. College Board and AP Central do not include endpoints for intervals of continuity or increase or decrease or things like that. So with that being said, I can draw the graph from -1 to 0 as x goes from -1 to 0. So that's one interval of continuity. And then I can draw the graph from 0 to 1 without picking up my pencil. So that's an interval of continuity. And I can draw the graph from x equals to 1 to x equals 2. That's the interval of continuity. And then I can go from 2 to 3. That's the interval of continuity. That's all I got to say about that.